Okay, so for today's lesson, or going over today's free response question, I'm going to mostly go over the general concept of these two questions, just because I want to make sure I can get to one that's both motion and rates. Now, I will tell you, I think this is 2017-5 for A, B, and B, C. So let me write that down. This is 2017 for A, B, B, C number 5. And this is a non-calculator question, so I could 100% see a question like this being the kind of question that you end up getting on your AP exam, because I think they're trying to cater it to non-calculator questions. Okay, that being said, obviously in this case you would have a calculator so you could type stuff in, but I want you to be aware of your derivative rules and things like that. So let's talk a little bit about motion first. Some of the things you have to figure out when you're working with motion is when to figure out if something is going left or going right. That's all based on the sign of the velocity. So they're asking you, when is particle P moving to the left? What you need to do is you need to figure out what is the velocity function for P. Now, if you notice, they're giving you the position function for P, which is actually kind of abnormal because usually they mostly give you velocity functions. So again, let's just pretend for argument's sake you don't have a graphing calculator and you have to figure out this value. So you're going to have to actually find the derivative of that ln function. So let's talk about just a recap real quick. If you have ln of u, its derivative, is 1 over u du. Okay, so therefore when you take the derivative of this function to find this velocity function, it's 1 over everything that's inside of that ln multiplied by the derivative of what's inside that ln, okay, and that's your velocity function. You want to find out when this object is left, so moving left, so when is this velocity negative, okay, so you want to find out when is this v of t less than 0. So basically what you should probably do is try to figure out where is it equal to 0. If you think about a fraction, the only way for it to be equal to 0 is for the numerator to equal to 0. So therefore you'd find out that t equals 1 is some sort of a changing point. Okay, so remember that you're talking about something that's, a time. It's not going to go any less than 0. So you want to figure out when is the velocity negative. The easiest thing you can do, again, you'll have a graphing calculator when you take your AP exam, but let's just say for argument's sake you didn't. Try plugging these values into this expression and see what happens. If I pick something like 0.5, right? 2 times 0.5 minus 2 is going to come out to be a negative number. Try and see what happens in the bottom. Eventually you'll figure out that it comes out to be negative between 0 and 1. Again, just playing with plugging in. It comes out to be positive when you're greater than 1, which means the object is moving to the left between 0 and 1 and moving to the right beyond that. Okay, so then the way that you would write that is that you would say that the object is moving left. You're assuming that it's actually going left to start, so actually at 0. But you would not actually say at 1, because at 1 the velocity is not negative, it's 0, so it's not, again, that particular direction. So this is the time frame when the object is moving to the left. If I wanted to know when it's moving to the right, I look when velocity is positive. Okay, find the times at which the two particles travel in the same direction. So find when this velocity function that you just worked with, and again you made a number line for it, and the other velocity function, find out when they're both positive or both negative. Again, you're looking for same direction. I'm going to skip a little bit ahead. Like I said, I don't want to go too much into it. You could look up the full solution online by searching 2017 ABBC number 5. I just want to make sure there's time to go over the rates question, and I don't want you to be watching a half-hour video. If you look at letter C, find the acceleration of particle Q at time t equals 2. Is the speed of the particle increasing, decreasing, or neither at t equals 2? It's important to make sure you remember that acceleration does not tell you if it's slowing down or speeding up. You need both acceleration and velocity sign at that specific point. Okay, so we're talking about finding the acceleration of function Q. So the or particle Q, I should say. So the acceleration of Q is going to be the derivative of the velocity of Q. So if I take that derivative, that's 2t minus 8. You're specifically looking at it when it's t equals 2. So if I do 2 times 2 minus 8, that comes out to be a negative. So I have at least acceleration is negative. And again, what I want to point out, do not make the mistake of thinking that just because acceleration is negative that the object is slowing down. You have to look at the acceleration and the velocity put together. So let's look at the velocity at 2. So label that this is acceleration at 2. when I look at velocity at 2, 2 squared minus 8 times 2 plus 15. So what is it? 4 minus 16 plus 15, 4 minus 1, so that comes out to be 3, so that's positive. So you would say that the object is slowing down, okay? And I know this because acceleration at 2 times velocity at 2 comes out to be a negative number, or you could say because they have opposite signs, okay? So I just wanted to point that out because that's a common mistake that sometimes people make. Last but not least, and this is where we bring in a little bit of integration stuff, find the position of particle Q the first time it changes direction. So you're going to need to figure out when does particle Q change direction. So look for when the velocity of particle Q is equal to 0. So if I take t squared minus 8t plus 15, if I factor that, that's t minus 3 times t minus 5. So at 3 and 5 is when the particle stops. Now you obviously would have to look to make sure that the signs of the velocity change to fully know that it changes direction, but you will end up seeing that that happens at t equals 3. So now at t equals 3, you now want to find the position of that particle. Things to remember when you want to find a position of a particular function, sorry, this is particle Q, what you need to have is what's the initial position, right? What's x sub 0? At what location did you know that initial position? At what location do you want the final position? And you should be integrating the velocity to work backwards to that position. So again, the important thing to remember is that integrating the velocity just gives you the displacement that tells you how much the particle has changed, but you need to add that to the actual initial starting location to get the final location. So we have to look back in the directions of the problem. They tell us that the particle Q is located at position 5 when t equals 0, okay? So you're located at 5 when t equals 0. You want the final position at t equals, at the time that it changes direction. So that's t equals 3. And the velocity function that we're working with is t squared minus 8t plus 15, okay? And this is going to end up giving you the position of particle Q at t equals 3. Now again, you have access to a graphing calculator, so I'm not going to go too much into this, but I wanted to make sure I reminded you that when you set this up, when you want a specific position of an object and you only have its velocity function, you need to integrate that velocity function from when you knew the initial location to when you want the final location, and don't forget to add it to the initial location itself. Again, I know that I'm not going fully deeply into the solution this time. You can look that up. I just wanted to cover some of those key points about how you would handle a motion question. So now I'm going to go on to a rates question. This one also happens to be 2017. It was an ABBC question. Okay, and this is obviously number 2. And again, I'm not going to write out every single detail of the solution. If you would like to see the solutions, you could just look it up on that, just Google 2017 ABBC, whatever the scoring thing is. I really just want to go over some of the key concepts that you need to know when it comes to a rates question. So if you remember, there's a lot of similarities when it comes to motion and rates. The only difference is that when we're dealing with rates, we don't say, oh, the derivative of the position is the, velocity, and the derivative of the velocity is acceleration. It's more like the rate of change. How do the rates of change tell you if something is increasing or decreasing, and things like that, okay? So you'll notice this is one of those what we call double rates question. There's a rate in and a rate out. So it's important to first identify what is the rate in and what is the rate out. Employees add bananas at this rate, G of T. So this is your rate in, okay? Customers remove bananas at this rate out, okay? Now you'll notice that these are not both on the same time frame, so you're going to have to be careful. It looks like in the first 3 hours, customers simply just remove, okay? So on the interval from 0 to 3, your overall rate of change is just the rate going out. Then once you get to t equals 3, now you have something where there's a rate out and a rate in, and you have to remember then that the overall rate of change, and again, like I just said, this is on the interval from 3 to 12, not on the whole thing, is going to be the rate in minus the rate out. So specifically, that's going to be G of T minus F of T. Now, you don't necessarily always need to be using the overall rate of change. Things you want to remember: you integrate a rate of change to see how much it changed. If you want to know an exact amount at a specific time, you start, adding the initial amount that you know, and then add that to the integral. Things we should maybe pay attention to: it starts with 50 pounds of bananas to begin with. So that's your initial value. But again, be careful, because there's different rates of change from 0 to 3 than there are from 3 to 12. Okay, so the first question says, how many pounds of bananas are removed from the display table during the first 2 hours that the store is open? By the way, I should mention this before I get started. This is actually a calculator question. Look at the nature of those functions. There's no way they're asking you to do those by hand. That being said, on your AP exam this year, they're not going to give you questions like this because they don't think that everybody has access to a graphing calculator. So you're probably going to have functions that are way more simple than this. That being said, who knows if you're going to get ones that are functions or if it's going to be pictures and tables. So you need to make sure that you're prepared for both. Okay, how many pounds of bananas are removed from the display table during the first 2 hours that the store is open? You're only looking for the amount of bananas that are removed, okay? So you're going to be integrating to find out how much. It says the first 2 hours of the store being open, and you're only integrating the rate at which it's being removed, which in this case is f of t. As I said before, I'm going to focus a little more on setup right now. If you want to go calculator, go right ahead, but I just want to make sure you go over some of those general concepts of rates. For part B, it says find f prime of 7 and using correct units explain the meaning of f prime of 7 in the context of the problem. So if you were doing a calculator-based question, you would have done like a Math 8 type thing. And when you did Math 8, you would have gotten negative 8.120 in this particular case. Again, you're not going to have necessarily calculator-based questions, but these concepts might come up as well, so it's important you make sure you know how to apply your understanding. So it says, using correct units, explain the meaning of f prime of 7 in the context of the problem. Okay, so you're talking in this case about not the rate of change, but the rate of the rate of change. So the fact that this comes out to be negative, it means the rate at which bananas are being removed is decreasing. Okay, so it's not the amount of bananas is decreasing, it's the rate at which the bananas are removed is decreasing at t equals 7. Okay, according to this f prime of 7. So the way that I could help you to understand what's happening with that, oftentimes in my class I use this analogy of like a bathtub. You're sitting in the bathtub, right? You're turning the faucet on, right? Bananas, or in this case actually you're removing bananas. So let's say you have the plug on the bottom of the what's it called, bath open, water is flowing out, but it's flowing out at a slower and slower rate. Okay, so basically like when you get to the bottom of the water in the tub, it's not flowing out of the tub as fast. That's what's happening in this situation. The rate at which the bananas is removed is decreasing. Okay, and this should be using correct units, so let's take a look. It's pounds per hour, okay? So it's pounds per hour per hour. Because of the fact that this is almost kind of like an acceleration in this case, even though we don't have acceleration when it comes to rates, because you're talking about the way that the rate itself is changing. You could also do that as pounds per hour squared. Okay, so part C. Is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? Okay, time t equals 5 falls into our interval with the overall rate of change. So for us to figure out if we're adding or subtracting bananas at that point, we have to compare the rate in and the rate out and see which one is bigger. The rate in is bigger, you're adding bananas. Rate out is bigger, you're subtracting bananas. Overall, let's see what happens. So in this case, you'd have to figure out what's the value of g of 5 minus f of 5. Again, this itself is a calculator-based question. You might not necessarily have a question like this, but I want to go over these concepts. When you start plugging in, you'll see that you get a negative value when you do g of 5 minus f of 5. The fact that that overall rate of change is negative tells you the bananas are decreasing at that particular point. Okay, so you would say, since g of 5 minus f of 5 is less than 0, the number of bananas is decreasing at t equals 5. Okay, and then finally the last question, and this one you're going to have to be careful with because this is one where you're using an integral to be able to figure out the overall amount at a specific time. So you have to take into consideration how much did you start with, how much did you remove over a specific time frame, how much did you add over a specific time frame, and watch your intervals. It says how many pounds of bananas are on the display table at time t equals 8. So remember that we're starting with 50 pounds of bananas to begin with. You're adding bananas, but you're not adding bananas the whole time. You're only adding bananas on the interval from 3 to 12. So when you integrate from 3 to 12, the function g of t, this is going to tell you you started with some bananas, you added some bananas. Don't forget that you're also subtracting bananas. So you're going to have to subtract the interval from 0 to 8, f of t dt. Okay, that's how much you've removed. And when you put that all together, in this case, it comes out to be 23.347. Did they say to round? No, but remember that here's the idea. You want to make sure that you leave your value, if you have to round, to at least 3 decimal places. Feel free to go longer. In this case, obviously, this was a calculator-based question, so I think you have no choice but to use decimals. But if this is a question where you're evaluating any of these integrals by hand, please remember you can leave unsimplified answers, and in fact, they encourage you to leave unsimplified answers. Okay, don't forget about units. This is pounds of bananas. Okay, so that's 23 pounds of bananas on the table at t equals 8. Okay, so I would encourage you to look back. There's almost always a rate and a motion question on every A/B test. On BC, I would say the rates questions are probably more likely than the motion questions, but I think it's still good to maybe go over both, and hopefully this kind of